Hello everyone, welcome back to the online class. Dear students, in previous video already I discussed about the concept of the magnetic field lines and the properties of magnetic field lines. And the next concept is magnetic flux and the Gauss law in magnetism. In case of electrostatics, already all of you have studied what is electric flux and the Gauss law in electrostatic. But in this topic, there is the Gauss law in magnetism. Before going to the statement of Gauss law in magnetism, I am going to discuss about the concept of what is the magnetic flux. Magnetic flux means it is the total number of magnetic field lines of force. The total number of magnetic lines of force or induction passing normally through a unit area around that points. Here this is the bar magnet. This is the bar magnet and A is the area. A is the area around this point. The number of magnetic field lines. This is the first magnetic field line. This is the second magnetic field line. This is the third, fourth, fifth, sixth, seventh and eighth. The total number of magnetic field lines of force. The total number of magnetic field lines of force or induction passing normally through a unit area around that point. ಇದು ಒಂದು ಸರ್ಫೇಸ್ ಏರಿಯಾ ಇದೆ. ಈ ಸರ್ಫೇಸ್ ಏರಿಯಾದಲ್ಲಿ ಎಷ್ಟು ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೀಲ್ಡ್ ಲೈನ್ಸ್ ಪಾಸ್ ಆಗ್ತವು? ನಂಬರ್ ಆಫ್ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೀಲ್ಡ್ ಲೈನ್ಸ್ ಆಫ್ ಫೋರ್ಸ್ ಆರ್ ಇಂಡಕ್ಷನ್. ಮ್ಯಾಗ್ನೆಟಿಕ್ ಇಂಡಕ್ಷನ್ ಅಂತ ಕೂಡ ಕರಿತೀವಿ ನಾವು. ಇಂಡಕ್ಷನ್ passing normally through a unit area. This is the unit area around that point. This is called magnetic flux. This is called magnetic flux. And from using this magnetic flux, we will define the Gauss law in magnetism. Magnetic flux or magnetic induction. It is mathematically denoted by the symbol B. And magnetic induction, it is the ratio of magnetic flux to the area. The flux per unit area or magnetic flux per unit area is called magnetic induction. And magnetic flux is mathematically denoted by the symbol pi and area it is mathematically denoted by the symbol A. B is equal to 5 divided by A. And its SI unit is expressed in terms of Weber per meter square. The SI unit of magnetic flux is Weber per meter square. Weber per meter square or Tesla. The SI unit of magnetic induction is Weber per meter square or Tesla. SI unit of magnetic flux is Weber. Area is meter square. Weber per meter square or Tesla. It is the SI unit of magnetic induction. And the CGS unit is Gauss. And 1 Tesla is equal to 10 to the power of 4 Gauss. Remember this point. 1 Tesla is equal to 10 to the power of 4 Gauss. Magnetic flux, it is mathematically denoted by the symbol phi. The total number of magnetic lines of force or induction. The number of magnetic lines passing normally through a unit area around that point or the number of magnetic lines of force or the number of magnetic induction passing normally through a unit area around that point is called magnetic induction. The ratio of magnetic flux to the area is called magnetic induction or the magnetic flux per unit area is called magnetic induction. The SI unit of magnetic induction is Weber per meter square or Tesla and 1 Tesla is equal to 10 to the power of 4 Gauss. 1 Tesla is equal to 10 to the power of 4 Gauss. Now the next concept and the dimension formula is m1 t to the power of minus 2 and a to the power of minus 1. It is the dimension formula of the magnetic flux. The next concept is the Gauss law in magnetism. From using the magnetic flux concept, it states that the net magnetic flux through any closed surface is always 0. Suppose if I consider this is the closed surface, yes. The closed surface, yes. Consider the closed surface, yes. It states that the net magnetic flux through, magnetic flux means the total number of magnetic field lines of force passing normally through a unit area surface at that point. These are the magnetic field lines. These are the imaginary lines. Here, the net magnetic flux through the any closed surface is always 0, or it means that the number of magnetic field lines entering the surface is always equal to the number of magnetic field lines emerging from that surface. ಒಂದು ಸರ್ಫೇಸ್ ಇದೆ ಇಲ್ಲಿ, ಇದು ಕ್ಲೋಸ್ ಸರ್ಫೇಸ್. ಈ ಕ್ಲೋಸ್ ಸರ್ಫೇಸ್ ಅಲ್ಲಿ ಎಷ್ಟು ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೀಲ್ಡ್ ಲೈನ್ಸ್ ಎಂಟರ್ ಆಗ್ತಾವೆ ಅಷ್ಟು ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೀಲ್ಡ್ ಲೈನ್ಸ್ ಎಕ್ಸಿಟ್ ಆಗ್ತಾವೆ. Then the net magnetic flux through that closed surface is always 0. It is very simple definition, simple statement. It states that the net magnetic flux through any closed surface is always 0, or it means that the number of magnetic field lines entering the surface, is always equal to the number of magnetic field lines emerging outside that surface. This is the statement of Gauss law in magnetism. Now here, this is the closed surface. Consider this is the closed surface. This is also called Gaussian surface. ಇದನ್ನ ನಾವು ಏನಂತ ಕರಿತೀವಿ? Gaussian surface ಅಂತ ಕರಿತೀವಿ. This is also called Gaussian surface in a uniform magnetic field B. This is the uniform magnetic field B, and ds is the small area vector of this surface. ds is the small area vector of this surface with the unit vector n. Along the normal drawn to the plane of this element. And normal to the element makes an angle theta with the direction of magnetic field. Normal to the plane or normal to the element makes an angle theta with the direction of magnetic field. And according to the statement of that Gauss theorem, in the magnetism, the magnetic flux phi, or it is mathematically denoted by the symbol phi b. The magnetic flux phi b is equal to, it states that the magnetic flux through any closed surface the magnetic flux through the any closed surface b dot ds is equal to 0. It states that the net magnetic flux through any closed surface is always 0. It means that the number of magnetic field lines entering the surface is always equal to the number of magnetic field lines emerging from that surface. This is a Gaussian surface. This is about the magnetic flux and Gauss law in magnetism.